Okay. In this video, we'll be discussing about a problem that is broken economy. It is also known as ceil and floor problem. So, in this problem, you'll be taking an input that is array. It will be sorted array. You'll be taking an input of sorted array, and here you'll be given a value. Consider the value as 32. We need to find a ceil and floor of 32. What is the ceil and floor of 32? If 32 is present, then it will be in between this point, right? Ceil. What is ceil? Ceil is the number just greater than 32. Just greater than 32 is 40. Okay. This is our ceil. Ceil will be 40. And floor is the number that is just smaller to 32. That is this point 30. Right. The smaller than 32 is 30 in this array. So this will be our ceil and floor. And one more condition, that is if the number is present, consider the number, the value that we have to find ceil and floor is 50. If 50 is given, then since the number is present in our array, both ceil and floor will be the number itself, that is 50. Right. Ceil and floor will be the number itself. Is not present, then ceil will be the next greater element or a just greater element. Floor will be the just smaller element. If number is present, then floor and ceil will be the number itself. Right. Now we try to explain a solution. What will be our solution here? So we'll use the binary search technique here to find ceil and floor. Let's take the same array, sorted array. 40, 50, 60, 70, 80, 90, and 100. This is our array. So in binary search, we know that this part will be our low, this will be our high, and this is our mid, right? Now we will initially take our floor as negative infinity and ceil as positive infinity. And the value that we need to find ceil and floor is, let's consider it as 33. We need to find the ceil and floor of 33. Right. So we'll check, is it equal to our mid? No. Since our value is less than mid, this right hand side will be discarded and high will move here. Right, high will move here. I will move here. Now, since we know that if the data is present, it will be present in this point. That is from here to here. If it's present, it will be present in this point. Then we'll set this mid, the previous mid, as our ceil value. We'll update the ceil value as 50. Now we need to find our mid. Again, mid is this point. Now data is greater than mid. If data is greater than mid, we move our low. When we move our low, we set out the previous mid as floor. Right? It's just like we are keeping a boundary. Like we are trying to make a upper boundary and lower boundary of the element. Now low is here. Then we'll find mid here. Mid is this point. Let's check. Now data is greater than mid. If data is greater than mid, we move our low. When we move our low, we update our floor value to our previous mid, that is 30. Right. Now mid is at this point. Let's check. 33, 40. 40 is greater than 33. That is, if mid is greater than 33, we move our high. Now high will be at this point. When high move, we set our ceil. That is, ceil will be 40. Now the condition doesn't satisfy. That is, lows will be less than or equal to high, but here low is greater than high. This low and high cross each other. When it is crosses, then it doesn't satisfy. Then it will come out of the loop and we got our ceil and floor. Right? Ceil of 33 is 40 and floor of 33 is 30, right? Again, we'll try to come up with a approach that can use in our code. What will be, we'll try to cover the conditions. 90, 100. Consider the element to be find is 61. We need to find the ceil and floor of 61, right? And we know that if we move our floor, if we move our low, we need to set our floor. And if we move our high, we need to set our ceil. That is, if we move our low to mid plus 1, then the previous mid will become floor. And if we move our high to mid minus 1, then the previous mid will become our ceil. So when low moves, floor is set, and when high moves, ceil is set. So this is low, this is high, and this point is mid. Now data is 61. Mid is greater than 61. Right? Mid is greater than 61, then low move. First of all, we'll initialize our floor with minus infinity and ceil with plus infinity. So data is greater than mid. If data is greater than mid, low move. Low will move where? And we'll set our floor. See, if low move, floor is set. Floor will be updated to 50. Now low is here, high is here. So low move, floor is set. So floor value will updated to 50. Now we got our new high and low. We'll get our mid. Now this is mid. Let's check. 61 is less than 80. That is, mid is greater than our data. Then we move our high. High will be here. When high moves, ceil is set. Right? And high moves, ceil is set. Then ceil will be updated to our previous mid, that is 80. Now we'll again find mid. Mid will be at this point. Now we check. 61 is greater than 60. If data is greater than mid, we move our high. We move our low. When we move low, we set our floor. Our floor will be 60. Previous mid position 60. Now find mid. Mid is at this point. We check. Is 61 equal to 70? No. 70 is greater than 61. If mid is greater than 61, we move our high. When we move our high, we set our mid. That is 70. Right. Now low and high cross each other. That is, low is greater than high. Then our binary search condition doesn't satisfy. So we'll come out the loop. We got our floor, that is 60, and ceil, that is 70. We try to write this in our code here. We'll be taking value. What will we be taking? We'll be taking n and a number. We'll be taking the size of an array first, then we'll taking the element of an array, then we'll take the number for which we have to find ceil and floor. N equals to scan next. This is for size, this is for array. Array will be of size n. This for loop will be for our inputs. We'll be taking inputs. This input will be in sorted. Right. The given array will be in sorted array. Now we'll take the data. For this data, we need to find a ceil and floor. So for binary search, we need low will be 0. We need high will be 1. High will be what? Length minus 1. That is n minus 1. Right. Again, for floor, we need to initialize with negative infinity. Negative infinity, we can write as integer dot min dot value. Right. And we can assign our ceil with positive infinity. Max value. This is what positive infinity. From here we'll start our binary search technique, that is low is less than equal to high. Right. In mid, we'll calculate our mid. I hope you already you remember the binary search technique. Mid, if, what are the three conditions? The three conditions are if data is less than area of mid. Then the second condition, that is data is greater than area of mid. Then our last, that is if data is equal to array. So in first condition, data is less than mid. If our data is less than mid, right? What are the conditions? If data was less than mid, then we move our high, right? If data is less than mid, we move our high. If we move our high, we set our ceil. Then high will be mid minus 1, right? And we set our ceil. Ceil will be area of mid. So if data is greater than area of mid, if our data is greater than area of mid, that is, if data is greater than area of mid, we move our low to mid plus 1. When we move our low, we set our floor. When we move our low, we set our floor. When we move our high, we set our ceil. So here low will be, that is low will be mid plus 1. And we set our floor. Floor equal to area of mid. Right. When it is equal, and when we got the element, if the element is present in the array, if it's present, what was the condition? Condition was floor and ceil will be same. Floor and ceil will be same. Floor is equal to ceil. Floor and will be same, and will break here. After that, we need to print our, what should we are printing? We should print our ceil, then floor. System output and ln. First, we need to print our ceil value, then we need to print our floor value. Let's run this program. Right, we are giving the correct answer. Let's try to submit and check. We're getting the correct answer. So I hope you understand this problem. Thank you.